Let's take a look at lesson 10.5. It's page 65 in your math composition book, and it is line symmetry. So let's take a look at a definition. Symmetry is a reflection of a shape. It's what it would look like in a mirror. A figure has line symmetry if it can be folded on a line, on a specific line that we'll decide, and the two sides match exactly when folded on that line. Let's take a look at two shapes here. Right here, we've got a shape of something that looks kind of like a tree. This figure is symmetric. It does have symmetry. And this is the line of symmetry. If you look at both sides of the line, they match exactly. This point matches exactly to this point if I folded it. This point here matches exactly to this point here. This point matches with this point. If you were to fold this figure all the way over to touch that side, both sides would be exactly the same. Now, if we take a look at this other picture, this is asymmetric. A means not. It does not have symmetry. This point does not have a point to match over here. This point does not have a point that matches here. If I were to fold this figure on the line, it would not match exactly the same. So this figure does not have symmetry. Let's take a look at the two stars here on the bottom. These two stars are 5-pointed stars, but the yellow one does have line symmetry. You can fold it right there, and we can see that the tip of the stars right there would match. We can see that these two would also match if I folded it on this line. Take a look at the blue star. If I take the blue star and I make a line across the blue star, I can see that this side here is much farther away than this side here. It does not have line symmetry. Let's take a look at some practice questions. So here we have some figures, and they have a line drawn. We're going to decide if this line is a line of symmetry. So let's take a look at the example. If I fold the figure along this line, this is where I'm going to fold it, are the two sides going to match? Well, it looks like this part is going to match with this part. So yes, this figure does have line symmetry. And this is the line. Let's take a look at number 1. Is this the line of symmetry on number 1? Yes. Let's take a look at number 2. Is this the line of symmetry for number 2? Well, if I fold it on that line, the answer is no. This shape does have symmetry, but that's not it. Let's take a look at question number 3. Is this the line of symmetry for this figure? No, it is not. If I fold it, I'm going to have this little part sticking out up here. Let's take a look at number 4. Is this the line of symmetry? Yes, it is. Looking at number 5. Number 5 actually does have a lot of lines of symmetry. However, the line that is drawn is not one of them. Question number 6 is a little bit tricky. Question number 6 looks like it has symmetry, but these lines are shorter than the bottom lines. So this shape does not have line symmetry. And we are going to practice folding some shapes like this. Let's take a look at number 7. if I fold it on this line of symmetry, will it have symmetry? And the answer is yes. I kind of gave it away when I said it was the line of symmetry. Number 8, does this figure have line symmetry? Is that the line? And the answer is yes, that is one of the lines. Now some figures have more than one line of symmetry, and we are going to take a look at that. Let's take a look here and see some figures that we already know. We've got a square, and a square has 4 lines of symmetry. Because all sides are equal and all angles are 90 degrees, I can do diagonals, line of symmetry. I can do horizontal and vertical lines of symmetry. Now this part kind of confuses us when we look at a rectangle, because a rectangle is very similar to a square. But because it has 2 lines that are long and 2 lines that are short, it does not have that vertical line of symmetry right there. That does not exist in a rectangle. So the rectangle only has 2, across the middle in both directions. Alright, take a look at this rhombus. This particular one has 2 lines of symmetry. It's got a horizontal line of symmetry and a vertical line of symmetry. But it does not have diagonal lines of symmetry. It does not, because the sides, the angles are not 90 degrees. Let's take a look at the kite. It's a shape that you will encounter in 5th grade, but we can still see it for symmetry. A kite only has 1 line of symmetry going vertical right here. 1 line of symmetry that is vertical. An isosceles trapezoid, well, it's called an isosceles trapezoid because 2 sides are the same. Remember, I saw with my 2 eyes, this side and this side, those are both the same. So it's called an isosceles trapezoid. And it has a 1 line of symmetry, only vertical. Vertical line of symmetry. A regular trapezoid, right here, it's not an isosceles trapezoid, does not have any lines of symmetry. There's no way that I can find a line to fold this, not this way, not this way, not this way, no way that I can fold this shape so that it is exactly the same on both sides. Here's another tricky one, a parallelogram. Most students think that a parallelogram does have line symmetry. However, if I were to make a line in the middle, look how long this side is and how much shorter this side is. If I tried to do it diagonal, I can see that right here means that I should have a corner right there. They should match, and they do not. Parallelograms is a very tricky one that confuses 4th graders a lot. There are no lines of symmetry. An equilateral triangle, because it is equal on all 3 sides, it's got 3 lines of symmetry. From one of the angles straight through the center of the other side, from the other angle straight through the center of the other side, and from the 3rd angle straight through the center of the other side. And the isosceles triangle, because 2 sides are the same, this side and this side are the same, it has the 1 line of symmetry. We're going to take some time to explore some actual symmetrical figures with our hands cutting paper so that we can explore how many lines of symmetry the shapes have. So this is lines of symmetry, page 65 in your math composition.